Greetings. I'm pleased to be here today to talk about unraveling the mysterious deep sea, one expedition at a time. I'd like to acknowledge and thank the Geography 2050, The Future of the World, for inviting me to present today. I want to start by talking about the deep sea. The backdrop of legends, movies, and superstitions, the deep sea has always been unfathomable because we had no idea what, if anything, existed there. Light is minimal and decreases with depth, leaving a cold, pressure-filled environment. Once thought to be barren of life, thanks to recent technological advancement, we know this couldn't be further from the truth. With every deep-sea expedition, it seems that something new is discovered and we gain a greater understanding of our planet and its intertwined systems. Since 2009, Schmidt Ocean Institute has been working towards better understanding these vast and mysterious systems, facilitating marine research with its vessel Falkor. From trenches, canyons, seamounts, and hydrothermal vents, Schmidt Ocean Institute has illuminated some of the deepest, darkest depths and has begun to paint a picture of what the ocean truly looks like. In less than a decade, Schmidt Ocean Institute and its collaborators have made a multitude of discoveries, including new species, geologic features, and mapped over 1.1 million square kilometers of seafloor in high resolution. In this time, we've uncovered new hydrothermal vents, upside-down lakes, and the world's deepest fish. The data collected has contributed to a better understanding of remote and deep-sea biodiversity, offering insights into how these systems influence nearby aquatic resources and help inform managers. These insights were made by new technologies, help with a 4,500 meter capable underwater robot named ROV Sebastian. We've also demonstrated new technologies on Sebastian, such as soft robotic fingers that can pick up delicate samples, or sifters to find meteorite fragments that had fallen to the seafloor, and 3D scanning and reconstruction instruments to image translucent animals. Some of SOI's most exciting discoveries have taken place this year in Australian waters. Surrounded by 3 oceans and multiple seas, the continent's deep sea ecosystems vary greatly and have largely gone unexplored with limited in-country research with deep sea technology. Schmidt Ocean Institute partnered with Australian scientists this year in exploring and capturing imagery of Australia's submarine canyons and coral ecosystems. The exploration-based research taking place on Falkor is informed by the science. The goal is to better understand what these marine resources hold and how they connect to ocean systems. Documenting biodiversity and fossil records is critically important for understanding deep sea environments as well as for resource managers. ROV sampling, or underwater robotic sampling, is currently the most exact approach for deep sea sampling, allowing researchers to gain a wide variety of information using highly targeted sampling techniques with minimal bycatch or extraction. Specimens, geologic, and chemical samples provide an important baseline to not only compare for future changes in species health and distribution, but environmental conditions and insights into the past. Schmidt Ocean Institute has brought the deep sea to Australia with its high-resolution live streaming using our 4,500 meter capable ROV Sebastian. Prior to this, Australia had limited deep sea underwater robots, which made these expeditions so important and rare. These mark some of the first time a science remotely operated vehicle with sampling and imaging capabilities have been able to characterize deep sea waters in Australia's system, allowing for unprecedented characterization of seafloor and deep sea. The dives that we do while at sea are live streamed and shared in perpetuity on Schmidt Ocean Institute's YouTube and Facebook pages so that the public can not only see what we find, but experience the excitement, the emotions, and the reactions of the scientists when we find it. What has been really unique this year as well is how collaborative the science has been through these live streams, and we'll talk about more how researchers have joined all over the world. Although it's been a challenging time for everyone this year, especially for marine operations, Schmidt Ocean Institute has been lucky. We've been able to continue this year partly because of where we were. We were already at sea during these expeditions around Australia when the pandemic started to take hold in mid-March, and also partly because of the technology we have on board. Falkor is able to conduct science at sea with scientists guiding with remote telepresence. And in the previous slide, you saw Dr. Robin Beeman from James Cook University leading an expedition in the Coral Sea from the comfort of his living room. In Australia's waters alone, there are 1,700 different species of coral and more than 4,000 species of fish. Prior to 2020, as I mentioned, little exploration took place below 200 meters. This is why Schmidt Ocean Institute committed to a year-long campaign in Australia. Of this year-long expedition, we've completed 5 of our 7 expeditions thus far, and we'll add 2 more into 2021. Today, I'll share a little bit more about the expeditions we completed and some of our new discoveries. In January, Schmidt Ocean Institute partnered with the University of Western Australia to examine Australia's south and west coasts. That expedition revealed stunning deep-sea coral gardens and the first whale fall found in Bremer Canyon. Bremer Canyon Marine Park was already known for its biodiversity, especially for things like whales and dolphins. But what we didn't know is how much of a hotspot it was for its deep sea marine species. We not only were able to look at some of these deep sea corals associated fauna, but also seawater and geologic samples from 4,000 meters all the way up to the continental shelf. Facing the Southern Ocean, the Bremer Canyon provides important information on the recent and past histories of climate change and ocean conditions as well. Because the Southern Ocean completely encircles Antarctica, it is the main driver of the global climate engine and helps to regulate the supply of heat and nutrient-rich waters to the major oceans. This is an important connection between disparate sites across the Southern Ocean, which has helped scientists trace changes in water masses forming around Antarctica, as well as the Northwest, as all the way into the Indian Oceans. On the next expedition, the unique fauna of the Cape Range and Cloides canyons in Ningaloo allowed scientists to document unexplored depths filled with glass sponges and octopus squid seen for the first time in Western Australia. This expedition was followed by observing the world's longest sea creature, the discovery of a 150-foot-long Saphonophore. This was in collaboration with scientists from the Western Australian Museum. The discovery of this massive gelatinous string, the Saphonophore, which is made of tiny individual zooids that clone themselves into specialized bodies and string together, was just one of the amazing unique discoveries of this expedition. They found fish and marine invertebrates, which were the deepest records for Western Australia. The Saphonophore, though, is an example of how exploration of ocean science can captivate the world. The discovery first trended on Twitter, resulting in 4 million impressions, and was picked up by news outlets all across the world, BBC, BuzzFeed, New York Times, and shared in more than 21 different languages. This year, we have not only lifted the veil of Australia's backyard, but shared amazing ocean imagery with the rest of the world. This has helped to captivate people in ways that they often hadn't thought about. After completing 4 months of research on the West Coast, Falkor transited to Queensland, focusing on the Great Barrier Reef and Coral Sea Marine Park. The Great Barrier Reef is one of the most iconic natural features on our planet, and while shallower corals are some of the world's most well-studied, these deeper reefs off the Great Barrier Reef have minimal exploration. Schmidt Ocean Institute had the first expedition in the Coral Sea Marine Park to take place virtually during COVID-19 restrictions. Scientists communicated and delegated tasks to the ship and ROV team from their own offices, beginning our first fully remote exploration of Australia. The footage played a vital role during these expeditions, and scientists were able to examine the health of deep sea species in the Great Barrier Reef and Coral Sea Marine Park for the first time. One piece of footage captured a rare deep sea fish. The range of the fish was thought to end in Hawaii prior to the sightings. Other discoveries included new species of black corals and sponges, as well as jellyfish. The extraordinary mapping effort that took place both in the coral sea and the Great Barrier Marine Park as well helped to illuminate a complex seafloor with 30 large coral atolls and banks, revealing submarine canyons, dune fields, submerged reefs, and landscapes. More than 78,000 square kilometers of seafloor were mapped, which is an area larger than half the size of Tasmania, transforming the Queensland Plateau from one of the poorest mapped to one of the best mapped frontier areas for Australia's marine estate. The maps will be available through AusSeabed, a national Australian seabed mapping program, and also contributed to the Nippon Foundation's Seabed 2030 project. Only the shallower parts of these reefs had been previously mapped, and until now, no detailed maps of the region in the deeper areas had been done. So what does the accumulation of mapping and diving with an ROV get? We feel like the lead scientists from this expedition from James Cook University and Queensland University of Technology summarize it best here.
We are really looking at ancient underwater landscapes. To understand the modern Great Barrier Reef, you have to actually look into the past and look at these ancient landscapes, because this is the base upon which the Great Barrier Reef has grown.
And nobody knew that this was here. This is the first time that we're seeing bathymetry images of the seafloor here in this region, and then the ROV video to go with it so we can see what it actually looks like down there. To try and explain what we're seeing, if you took the Grand Canyon and added on the Niagara Falls times 2, and then flooded that with seawater and stuck a coral reef on top.
In some places, we're really scratching our heads as to try and understand, how do you explain this? But certainly we're looking at something that is far, far older than the actual Great Barrier Reef itself. Now, when we put the ROV down to have a look, what we are seeing are numerous, I'm talking dozens and dozens of large drowned reefs.
We have to go back in the past to times where sea level was not at the same position that is now. We have reefs growing at sea level, very close to sea level, but the sea level rise, and they finally get drowned. One thing that we see when a reef is drowned is the sequence of organisms that are living on that reef. It starts with shallow water coral species. If sea level rise a bit, that coral species are substituted by a bit deeper coral species. If sea level continues to rise, the biology change. We can more or less estimate the speed of the sea level change in the past. So we can compare if those sea level changes occur at the same speed that they are occurring now. So we can say if it's a natural process or it's an anthropogenic induced process.
But living on and amongst all of this deep landscape are really quite amazing animals.
The deeper we go, the weirder it gets. Almost everything we see is a new observation that's never been seen in this region before, or even a new species, an undescribed species, or even a genus. For me, it's very interesting to see how the community changes as the geology changes. So the geology dictates what type of habitat it is, and therefore what type of community will colonise.
Well, we try to understand, because it helps us understand the Great Barrier Reef itself. They are intimately joined. The shape of that ancient underwater landscape is related directly to how the Great Barrier Reef grows on it. And so what we're looking at is a really remarkable landscape. Like, I have never seen such an amazing seafloor.
And then, much to everyone's surprise, another large discovery happened. On October 20th, as scientists were mapping the detached reefs of the Great Barrier Reef, the team revealed a never-before-seen 500-meter tall reef, the first of its kind to be discovered in over 120 years. The 500-meter height makes it taller than the Empire State Building or the Eiffel Tower or the Auckland Sky Tower, the tallest structure in the Southern Hemisphere. How was this never discovered? How was a 150-foot long Saphonophore never discovered? These are the types of things we are finding with our technologies that we are able to explore. The new reef was missed in previous mapping expeditions in the 1800s, which were some of the most comprehensive seafloor maps of these detached reefs up to this year. LiDAR data did not capture the reef either, likely because it sits 40 meters below the surface and had a very narrow top. Discoveries as grand as this one emphasize the necessity of multi-beam mapping to create high-definition maps of the seafloor. As we heard today from Dr. Robin Beeman from James Cook University, he was ecstatic. Him and his science party were on board Falkor during the time of the discovery. The science team subsequently did a robotic dive with Sebastian on this new reef, determining that the base was an ancient reef, possibly 20 million years old. At the top, there was a thriving ecosystem showing schools of fish, sharks, soft corals, and sponges. The news and the dive garnered international attention again and is still collecting press today, with more than 400 stories later in 27 different countries. That same week, on the last dive of this year, ROV Sebastian documented the first ever sighting of the Ramshorn squid. This was particularly interesting as it was rare to see this squid alive. Its open coiled shells are often found washed up on beaches, but never seen live in the ocean. At rest, the species generally maintains this vertical position that we caught it on while it was filmed. Again, this got picked up by press and has been making its way around the world, exciting scientists from all over. The results from Schmidt Ocean Institute's Australia expeditions will be able to be used in future marine management decisions of Australia's vast marine estate. The quantity and quality of data has opened up a new realm of possibility for deep sea research, and many scientists predict they will be answering questions with this data for years to come. All 5 expeditions demonstrated the necessity of interdisciplinary and collaborative research for deep sea exploration. The numerous partnering institutions and various experts each played a role that was vital to these discoveries. While COVID-19 restrictions posed a significant challenge, scientists were still able to participate safely and remotely. Technological innovation and public participation through open sharing of information has proven indispensable ocean research and discovery. While deep sea exploration comes with its fair share of challenges, there are still many more breakthroughs and discoveries to be made. With every expedition and every dive, we learn more, understand more, and can do more to protect our ocean that sustains every living being on our planet. Thank you very much.